Kia ora koutou, Reese from QuickSense here, and today we're looking at sets and subsets. Now this question is asking us to discover or give them how many distinct proper subsets of R there are. Okay, and what this means, well, distinct here means different. Right, so I can't have one is A, two is also A. They are proper in that they do not include the whole. So does not include the original set. So A, B, C, D is not a proper subset of R. Now, immediately what you might want to do is just to try and list all of the different possible subsets. So you may start by going, well, there's A, and then there's A, B, and A, B, C. But what you'll notice is that this is actually a trickier thing to do than you might expect. A better way to do about it is think about how many different possible elements can I include. So for example, if I am thinking about this in terms of something that goes here, something here, and something in this space, remembering I can't have 4 because there's only one way I can do A, B, C, D with 4, and that's the original set, which is not included. So how many different combinations can go in that first slot? Well, A, B, C, or D. Well, if I've included one of them in the first space, how many different possibilities are there to go into the second space? Well, I can't include a number twice, but I can include no numbers. So let's say I use an A here. Well, what are the possibilities for the next space? B, C, D, or nothing. So once more, we've got 4, right? So let's say that I used B. If I use B, then how many different set spaces are there for the next one? Well, there is A, B, then C, or D. So that's 2, but we can also include nothing. So 3 here. So how do I know how many distinct proper subsets? Well, I'm going to multiply these combinations together. So 4 times 3, 16 times 3 is equal to 48. So how many distinct proper subsets of R are there? Well, without having to count them all, and you can see 48, we're probably going to miss 1 or 2, I can tell, or I know, that there are 48 distinct proper subsets. In this next question, we're asked to find the range for the possible values of n of A, and we're given some information, some statements about A and B, right? So A intersection B is 2, 8, and 12. So that means that 2, 8, and 12 are included in both A and B, right? So we think about this in terms of maybe a Venn diagram, right? So this part here is the bits in here. And A or B, right, A union B is the whole thing. So what is the possible range of values? Well, we need to know what's the minimum number of elements that are included in A. Now, it's not the range of the values between the values in A. This question is asking us about how many elements are there in the set. So in A, well, I could have only 3, right? Because these could be all that's in A, right? This could be all that's in A. So what does that mean? Well, A could be as small as 3. Because you can think of a Venn diagram, right, that looks like this, where this is A, and this whole thing here is B. So A is a subset of B in this idea. And what's the largest? Well, it could be the other way around, right? Instead of A being a subset of B, B could be a subset of A. So if that's true, well then A is all of these elements here, And what's the largest number we can have? Well, A or B is 2, 4, 6, 8, 10, 12, 14, which is 7 elements. So what is the range for possible values for n of A? Well, it's greater than or equal to 3 and less than or equal to 7.